Hello community! Today we're gonna optimize our LLMs here for a very particular task if we use AI system for the interface to our customers. And you might say, hey, for the business AI, we have Salesforce and they have here the perfect Einstein Copilot here. Well, unfortunately, it is not that easy. So let's see where AI research is happening today. And there's a new challenge from our LLMs. And this is not to develop a system, an AI system, but to achieve consistency. Let's talk about automating our AI-based customer service interaction for optimizing here for the human experience. So, what is the problem we're going to solve today? Easy. It is about the customer service chatbot performance in accordance to the human expectation in interaction with your human customers. Let's say we have a scenario for an online retailer store where the customer are asking here about the return policy. Now, those inquiries by the human may vary widely in the phrasing. For example, it can be, how can I return a purchase? What's your policy on returning items? Or can you explain to me in detail your return process? Now, despite all those different formulations, the AI has to understand that the all same information, they seek here the same information. And there's a challenge for our traditional LLMs, because a normal LLM without a specific training might treat this all as distant inquiries, requiring separate responses, leading to inconsistencies. And we do not want this. We want our customer service AI to perform perfectly and according to our predefined company procedures and processes. So we need a new enhanced semantic alignment training for our LLMs. Because what we want, that we want to have a consistent and accurate response by our AI system to variously phrased questions by our human customers. So we want to improve here our customer satisfaction. We want that the users feel understood and they receive some reliable and valuable assistance. So we improve the consistency and reliability of our LLM responses. And this is not as easy as you might think. Because with our LLMs today, we have a challenge. And the challenge is that we have to address this issue, and there's a new research, a new approach to enhance the instruction following robustness of LLMs. Let's have a look at this research. And you say, hey, wait, this is from Baidu. This is the company that is now maybe cooperating with Apple in China for the new Apple AI systems. And according to the common knowledge, filming here today, and you see this publication here of end of March 2024. Yes, this is the company that Apple may cooperate with in China, following here the governmental regulations. So if they care about improved robustness of LLMs via a new consistency alignment phase of our LLMs, we all can learn from this. So let's have a look what our colleagues in China did and what was their main idea. Now, they thought about, hey, in a company, you have standardized company procedures. You optimize for these procedures. They are cost-effective procedures. And you want to create a brand to your customer. And you want to establish trust that the customers come back and they know what to expect from your company. And therefore, we have to train our LLM a little bit more in order to establish here this trustworthy relationship. Now, the technology is easy, and you know this, just 2 steps. That's all there is to it. You have an instruction augmented supervised fine-tuning and a consistency alignment training. And yes, you guessed it, this is simple supervised fine-tuning and a DPO process. But let's look a little bit deeper what they do. The initial phase, you have here an augmentation task instruction that respond here with various paraphrases here to guide here the model instruction following fine-tuning process. They do this here with a Vicuna system, with a Llama 2 system. And GPT-4 generates here paraphrased instruction. And you have here again here that the GPT system here generates syntactic data. The second step here, we have now, they call it the cat phase, by the way. We call it a DPO process. And we have here employs automatic feedback to train the model in recognizing and rewarding consistencies in response to varied instruction paraphrases. We have here direct reference optimization, DPO, where the responses are generated for each paraphrased instruction and evaluated. So if you want to see here a simple scheme of this, it's a two-step process, A and B. And in A, you notice we have here, after we created those paraphrases, after this paraphrasing process, we obtain at most n similar task instruction for each task. And we use this paraphrased instruction set along with the original instruction to have a supervised fine-tuning process of our model. You know this. And then it is a familiar step to go to the DPO alignment process, where we continue to train the model to learn which responses align with the human expectation better. And we do this by using here consistency rewards to differentiate the generated responses. It looks simple, but remember we are again here in syntactic data generation. And you might say, hey, wait a minute, your last video, you were already talking about syntactic data for fine-tuning when LLM talk to LLM. Yes, now we are in the same part of our research, but now we do not just generate some training data out of a domain, but now we have to have a next step. We have to find similar paraphrased sentences. So we need a deeper understanding of the human language now. And you might say, so what is the task? What is the prompt engineering that I need to do? And here you have the original prompt here from the authors of this paper. So the instruction for generating here the paraphrasing is, hey, GPT-4, paraphrase the input sentences to have different words and different expression, but have the same meaning for us human as the original sentences. Output the various paraphrases separated by a specific token. And note that you should not answer the question, but you should just and only paraphrase it and provide us with 10 more paraphrased sentences that have the same meaning as the original sentence. You see, this is all there is. And of course, if you want to determine now if those instructions are the correct answer, this is now here the prompt optimized prompt that the authors use here for this system. So you see, it is rather simple how they built here this interaction to generate new paraphrase sentences and then simply align it with what we expect. Let's talk about the infrastructure and the cost. Here, the first supervised fine-tuning, they used here a Vicuna 7b and a Vicuna 13b model. And the paraphrased elements were generated either by ChatGPT or GPT-4 on a small GPU node of 4 times an 80 gigabyte A100 GPU node. And then for the DPO, they used the Vicuna 7b, 13b, Llama 2 7b, and Llama 2 13b. Of course, they made use here of the low-rank approximation here on another node of 4 times a 40 gigabyte A100 GPU cluster. And for the dataset here, they have here a beautiful dataset, the supernatural instruction dataset, which consists of multiple thousand diverse tasks and answers. So there you have it. And if you have seen here a video where I told you, hey, there's a new idea instead of supervised fine-tuning and then DPO alignment, what we do here now, there's a new technology called here ORPA. And I made a video where I showed you and explained to you what it is. And you might ask, hey, can we now use this brand new technology just published 2 days before Baidu published its research results? Well, guess what? So Let's focus now on the results that we have, and you have benchmark data, standardized benchmark data, and one of these is ROUGE. And you can either go here with 1 grams, or we go with bigrams, whatever you like, or you go here with ROUGE AL, and this simply evaluates here the match of the longest common subsequence of words between the two texts. So whatever benchmark you choose, they published here the data on ROUGE, and you have here as a benchmark here the vanilla GPT-4 and the vanilla ChatGPT, what they can achieve out of the box. And then you have here our Vicuna 7B, just here 17. If we do a supervised fine-tuning, we go to 40%. If we do the supervised fine-tuning for our instruction augmentation that we just had a look at, we go to 41%. And if you do here the CAT process or the DPO alignment, as we call it, you go from 41 to 43%. Now, you might say, hey, the normal supervised fine-tuning is 40. Now we go to 44 almost. Yeah, this is the performance on a 7B model. But if you look now at Vicuna 13B, you start with 21. You immediately jump to 42%. With now our new learn process, we go to 44 and 46, so almost 47%. This is interesting because now look, if we reach almost 47% here in this benchmark data, and this is just one, and this is not the perfect benchmark, it is just one of many benchmark data. And the authors presented us this data set, but you see here with 46%, you are almost surpassing here the vanilla GPT-4 performance with 45%. So this gives us here a very nice idea for some additional fine-tuning and some additional DPO alignment here for our customer chatbot interaction with our human customer to improve the performance of the system. Beautiful. And then just to show you, they also did this here on the Llama 2.7b. And now we compare here the Vicuna 7b with the Llama 7b. And you see the Llama 2.7b starts at 6%, and even in the best case reaches only 31%, where the same size, the 7 billion free trainable parameter model, instead of 31, we reach here with Vicuna 43%. So you do have a sensitivity which base model you use for this particular process. And I guess it has to do with the training procedure, with the training data set and everything about it. So be careful on what model you use this particular process. It will give you significant different performance results. And the author noticed that there are limitations, of course. And they say, hey, our training approach here relies on the model self-rewards. So if the performance of the model's alignment is poor, the rewards we obtain may not lead to further improvements. And therefore, they go here with the best model that we know. Either you go with ChatGPT or with GPT-4 Turbo or whatever model you choose, but it must be a real powerful model for this self-rewarding. Otherwise, your improvements here of the performance of the system will be very, very limited. So you see here another video about now not let's find new models. No, we have our LLMs, and now we have to increase its performance in real-world tasks. If you have a customer interface, a user interface, we have to optimize our LLMs now for the human interaction. And this is where this is at the end of March 2024, the AI research is focusing more and more improve the performance of our LLMs. But you know, there's also some nice insight, because the more I read about the research currently, we see we need, and I mean we as a community, as a scientific community, as an AI community, we need one superior LLM. And either it is the upcoming GPT-5 from OpenAI, or any other Microsoft or Google company comes up with a better LLM, whatever there is, but we need one superior LLM with the content of the complete internet, more or less. Because from this one LLM, for all other smaller LLMs, we need this to generate our syntactic data, to generate similar data, to generate paraphrasing data, to generate new domain data, as I showed you in LLM to LLM. When a bigger LLM teaches a smaller LLM new stuff, we all need this for the data generation, but also if we train them for a higher performance of our edge LLMs that you might have on your phone or on your tablet or on your local computer. So this need of a superior LLM becomes really, really visible in all this research to generate here the syntactic data and to generate high performance syntactic data. So to accumulate here really the knowledge of the human civilization from all the different places, from all the different topics, from all the different domains that we have in, I hope, a lot of languages. If we bring them together to have one, I would almost call it a global LLM with this knowledge. We just need one. But it is so important to have this one for our downstreaming here, the knowledge and the abilities to build here smaller LLMs, to build fast and, I don't want to call it cheaper, but not so expensive LLMs for industry, for research, and for here customer applications that are augmented here with artificial intelligence. I hope you enjoyed this little video, and it would be great to see you in my next video.